I'm Matt Kaplan, now the Senior Communications Advisor for the Society, formerly, of course, for 20 long years, the host of Planetary Radio. By the way, I am told by Amber, no limitations anymore, if there ever were, internationally. So I believe we have people, I know we've had people in the UK before. She says that we have participants right now from Canada, Norway, and Austria in the chat. So welcome to all of you around the world. And questions are starting to come in, Lou, there in the chat. So we'll be getting to as many of those as we can. As always, I have a ton for you as well. I'm going to start with the little intro that I prepared, even though we've actually been talking now for about 10 minutes. Dr. Louis Friedman, co-founder and executive director emeritus of the Planetary Society, is the guy who hired me 23 years ago. I'd been a volunteer a little bit before that. And then he allowed me to start a geeky little show called Planetary Radio. Alone but Not Lonely, Exploring for Extraterrestrial Life is his latest book. And I hope all of you have enjoyed it as much as I did. Lou was the very first guest on Planetary Radio. He has been heard many times since, including a great conversation about Alone but Not Lonely with my colleague, new host of the show, Sarah Alamed, just 3 weeks ago. You can check that out on the website as well. Lou, it is always a pleasure and a great opportunity to be able to have a conversation with you. Welcome to the book club.
Glad to be here. I'm glad to see you're doing something new, and glad to with the book club here. That's exciting.
It is, yeah. And I know, because I've seen I participated in a lot of the discussion already, that most of the folks out there, if not all, have read the book. So you'll forgive us, folks, a little bit if we cover some of the basic territory, but we'll try to keep in mind that you have gone through the book. I love that you started the book right in the first paragraph with that great quote from your friend and partner in the Planetary Society, Carl Sagan. And here it is. If you are not interested in whether life in the universe is unique, just us, or ubiquitous everywhere, then you must be made of wood. I don't think anybody watching us right now, Lou, is made of wood, is wooden.
I think,
you're getting a lot of calls.
No, I should turn that off, but I don't know how to. No.
All right. We'll just get a little serenade.
Those aren't calls, by the way. Those are messages. But go ahead.
Okay. So, Lou,
the
point being that everybody watching right now, by definition here in the member community, is a member of the organization that you helped to start. And I just, maybe you would like to open with something about saying something about what it means to be talking to the people in the organization that you started, 43 years ago?
Well, it's correct that the subject, I opened with that quote because the subject of extraterrestrial life is enormously interesting. And it comes from the early part of the book deals with this. It's been in our religion, in our folklore, our stories for all of human history. Then it's been part of mythology, and then it became there's all kinds of pseudoscience connected with it. And it's only been in the last 60 years or so that it's actually been part of science. But it's an enormously interesting subject. At the same time, it's a subject without subject matter. So anything you say about it is conjecture at this point. But my experiences with the Planetary Society ever since day one have always been that you start to talk about anything off of Earth, and the first question you get is, do you think there's extraterrestrial life, or what might it be like? And most of the time, people are making a confluence of life and intelligence. And in this book, I try to make a big separation of that because those are two very different things to think about. But it's really wonderful. I remember a meeting with Carl Sagan and Bruce Murray, and I actually don't remember which of them said it to the other, but we were discussing the extraterrestrial life question and how to weave it into the Planetary Society mission statement. And either Bruce said to Carl or Carl to Bruce, he said, you know, this whole subject of search for extraterrestrial life, what we're really doing is searching for ourselves. And that's why it's so important. And that's true, because goes to the fundamental question of what is life? What is the relationship of life to the universe? What are the laws there? And how do they affect us and our place in the universe?
I'm going to jump right to the end of the book where you use that wonderful T.S. Eliot quote that you obviously love as much as I and a lot of other people do. You know the one I'm talking about. We shall not cease from exploration, and the end of all our exploring will be to arrive where we started and know the place for the first time, and apparently know ourselves for the first time from what you're saying.
Now, let me tell you, Matt, that in the course of working on this book, I wanted to quote the entire poem, the Little Gidding, and I wanted to quote the entire thing. But for that, as opposed to just the excerpt, I had to get permission from the publisher. It was quite an extensive thing because the publisher in England, and so the publisher, the rights to it couldn't be gotten here, and then my publisher couldn't do it on my behalf, so I had to do it. I got into a good discussion with them, but basically they wanted so much money for the rights to republish the entire poem. I decided, well, I'll just go with the thing and let other people look up the entire poem. But because that was the essence of it, to know ourselves for the first time.
And it is a terrific poem. I highly recommend that people Google that when they're done here. I'm going to go back toward, well, it's really more in the middle of the book, but it's the most upsetting and disappointing thing that I found in the book, though you insist it shouldn't necessarily be disappointing. I think you actually admit you were a little disappointed yourself. You take readers step by step through the Drake equation, replacing its variables with, either with numbers that we now actually know are realistic, or with your best guesses, and you arrive at one active, intelligent, technologically advanced civilization in the Milky Way galaxy. And where do we find that civilization, Lou?
Well, there's a debate about that, whether we have an intelligent species here on Earth, but that's it. And that's the essence of saying we are probably alone in the universe, or at least if we're alone, the notion of civilizations being able to evolve to show themselves to the universe technologically, or to be aware of the universe in some sense. That is how we define intelligence, is rare at best and maybe unique, and maybe an accident. I even have a chapter in the book in which I argue somewhat that the evolution to intelligence may just be an accident of evolution.
What's really troubling to me is that when I figured, okay, maybe Lou's off by a big amount, let's say 3 orders of magnitude, that means that there could be 1,000 active technologically advanced civilizations in the Milky Way galaxy, but you spread that over 17 trillion cubic light years, if the number I found was correct. It makes it unlikely that our nearest neighbor is going to be very close by. It's going to be tough to say hello or even find them.
Well, that's true, and space is mostly empty, and in addition, but I hope we don't dwell on that aspect of it, because to me, the thing that motivated the book is the part of we are not lonely. There's a lot to explore out there, and the exploration of exoplanets is opening up whole new vistas in which I see a future of us discovering a lot about life in the universe. Not intelligent life, maybe, but life in the universe, which will be very meaningful to us.
So, I mean, maybe pessimistic is the wrong word, but as pessimistic as you are about finding other intelligent life, really, you are thrilled by the thought that life may be ubiquitous, even if intelligence isn't. Is that fair?
Yes, that is fair. That what we have found on Earth within the first few 100 million years out of our 4 billion year history is life was here. We don't know if it originated here or got here by the accumulation from debris from outer space, but somehow very quickly in this planet's history, life formed. And so we think that that could be a process that's ubiquitous in the formation of planets. And what we've learned in our already in just a few years of discovering of exoplanets is there's many potentially habitable exoplanets out there, probably hundreds of millions, if not billions. And so the chances of finding worlds with at least primitive life on them is really very, very good.
Hasn't the Planetary Society, hasn't it been at the core of our mission right from the start, this search for life, intelligent or bacterial? Hasn't that been really important right from the start?
Yeah, I need to admit that when we formed the Planetary Society, and with Carl and Bruce in the early discussions, I was not a particular enthusiast. Remember, this was a time when astrobiology didn't even exist as a word, let alone as a discipline or a subject. And our knowledge of the solar system was very limited in the sense of knowing about oceans on the outer planet, moons, and things like that. And but it was the insights of Carl and Bruce that put that right into our mission statement right away. The exploring of new worlds, and the search for other life is the way I think we defined it in our original mission statement. And so it became, and then when amusing story, we were arguing a little bit, not arguing, we never argued, when we were discussing.
That's a joke, everybody, that's a joke.
The name of what would become the Planetary Society, and we were flirting with some other names that had spacey things in the title and stuff. And I poked at Carl a little bit, and I said, because he came up with the name. He did it under pressure, by the way. He was going on a television show. I think it was a Johnny Carson show, but he was going on a television show, and he said, I want to talk about the society, but we don't have a name yet. So we worked hard to solve that problem. And as he came up with the name of the Planetary Society, I said, well, the search for extraterrestrial life doesn't get into that title. He said, Lou, if we ever discover life not on a planet, we'll deal with it then. So that's what led to the name, the Planetary Society.
Hey, speaking of coining names or phrases, at least, I really like your reference to comparative astrobiology, which I think you draw from comparative planetary geology.
Yeah, that I hope is one of the contributions of the book, is because one of the motivating, or how I got into this subject was in a deeper way, was work I've done in the last 5 or 6 or 10 years since I've retired. I've been working with colleagues at JPL and Aerospace Corporation on something known as a solar gravity lens, which has the ability, which we call nature's telescope in the book there, which has the ability, if we could get to the focus of the solar gravity lens, we could magnify an exoplanet by 100 billion times and actually see it, something we can't do from Earth or even from space around Earth. And so there we might, using the solar gravity lens focus of many habitable exoplanets in the future, we might be able to see life on many worlds. And so I imagine the idea of comparing life on different worlds, the way we've been able to compare planets on different worlds here in our solar system. And we've learned so much about the environment and evolution of planets and of Earth from comparative planetology. I think there'll be someday in the future we will learn about life, our life on Earth, from comparative astrobiology, studying many planets.
Let's talk more about those SGLs, the solar gravitational lenses. And you said that they would allow us to see some of these exoplanets. To clarify, not just see them, I mean, there are, a handful that we've actually been able to image so far, but it's not much of an image, like less than a pixel, I think you
Yeah,
say in the book.
we get less than a pixel from
Yeah.
anything that's here on Earth, even the largest telescopes, even the imagined largest telescopes, even the ones that are being built, like the 30-meter telescope, and anything that could be built in space would also be limited just by the distance to the exoplanets. So we can't even get a pixel resolution. That means we can never see continents or forests or oceans or anything on an exoplanet. Now, we do get a lot of information from the spectra of exoplanets, and we're able to deduce what gases are in the atmosphere. But even if we see what those gases are, we don't know where they come from, whether they're global processes or whether they're processes that are connected with something like life or photosynthesis or things like that. So to overcome that limit, there's no way we can do it in our solar system. And the only way we can do it is to get out to the solar gravity lens focus, which is formed by the bending of light rays as they go around the sun, the relativistic effect that Einstein taught us from the curvature of space-time. And if we can get to the focus, we could get this magnification and actually see continents and forests and oceans on other worlds. Trouble is that's 600 astronomical units away, which is far. It's 4 times farther than Voyager has gone, even to date, but it's a lot less than 250,000 astronomical units, which is the distance to the nearest star. So 600 AU is within our reach, and so that's the push that I would hope that this book generates, is the idea that we can someday do missions to the solar gravity lens foci of interesting, potentially habitable exoplanets.
I was also fascinated to read in the book that this focus, it's not a point in space, it's actually a line.
Yes, because the light rays, when they bend around the sun, different distances, it's an extended object you're looking at, so there's a light ray and another light ray above it, and so they bend at different angles, and so the nearest focal point is 547 astronomical units, but then there's a whole series of them going out to infinity, actually, and so you have a focal line, so you don't have to get to the focus point and stop, which is what a lot of people might ask about a space mission. All you have to do is get on the focal line and keep flying in a straight line outward and look backward through the solar gravity lens.
I want to get to how we might actually reach this focus, with this, which is also something you address extensively in the book, one of your other great loves, through sailing. But before we do that, you mentioned, and it's fairly brief, but you give credit to your good friend Slava Turashev, who you have worked with for many years. Hasn't Slava sort of been the lead in this research for a long time? And just talk about that what he's been able to accomplish in proving the concept.
Yeah, it was I think it was either the year after I stepped down from the Planetary Society, or maybe even the same year. I was co-leading a workshop at Caltech, with the Keck Institute for Space Studies, on the subject of the interstellar medium, the exploring the regions of this that are beyond the heliopause, 200, 300, 400 AU, the regions that Voyager hasn't quite gotten into yet, and that heliophysics scientists want to reach. And Slava was invited to give a talk there. And when I heard his talk, it was a revelation, because he was talking about this solar gravity lens and the ability to image exoplanets. And that to me was an exciting. I'm always interested in something that, a mission that can do something that otherwise couldn't be done. And that was it. And Slava's been leading, published probably now maybe 50 papers in astrophysics journals on the subject of the solar gravity lens, which is very, very complicated, by the way. It's not a simple idea. It's not a simple bending of light rays that forms an image. It's done by the relativistic effect, as I mentioned, from the bending of light around the sun, and the image is formed in an Einstein ring around the focal line.
There's one right on the cover.
Yeah, it's used for galaxy observations now, and so it's very convoluted, and to deconvolute it takes a lot of computational power. And Slava's been working on this for a number of years. He's done research on that. He's won several grants from the NASA Innovative Advanced Concepts on it, including a very rare phase 3 grant. And that's where a lot of the work that I report on in this has been done. So yes. But Slava, by the way, should be known to Planetary Society members from earlier work that he did, maybe, 20 years ago, on the Pioneer anomaly.
Yeah.
He was the one who discovered these mysterious perturbations in the Pioneer spacecraft that was headed out past Jupiter and Saturn out to the interstellar medium that couldn't be explained, and maybe there was some law of physics that we didn't understand. Turned out to be some law of engineering that was going on in the spacecraft with the reflection of heat on the spacecraft that was causing these perturbations. But it was a very interesting study. Planetary Society supported it when no one at NASA would. We stepped in and raised money to provide the means to get the support so that Slava could conduct that research.
And it was no mean feat, digging up all those old data tapes and finding ways to read them. I was kind of disappointed when it turned out that Slava had not discovered the basis for warp drive or something like that. But hey, that's science. You go with you go with the truth. You go with the facts you find. About getting out there, is it the Breakthrough Starshot project that you are specifically an advisor to, or is it the entire Breakthrough Institute?
I'm an advisor on the breakthroughs. I'm an advisor on the Breakthrough Starshot.
Yeah,
which has this idea of trying to enable interstellar flight with laser sailing, which is a little different than solar sailing. Laser sailing, you apply a huge laser impulse at the beginning of the flight and get up to 20% or relativistic speeds very quickly. Mm-hmm. Within weeks after launch, and then fly out at 20% the speed of light. But it takes a 500 gigawatt laser, and all you can send in their concept is 1 gram, not 1 ounce, but 1 gram. I don't consider it too practical, and that's to the nearest star, not the most interesting star. So even though I'm on their advisory group, most of my advice is that's not the way to explore for extraterrestrial life. You ought to be focusing on the idea of doing it remotely. The ideas of interstellar flight are barely possible and mostly impractical.
To say nothing of humans actually making the trip, which
to send 100 kilograms to the nearest star again, not the most interesting, with the nearest exoplanet, again, not the most interesting. So send 100 kilograms, which is, me, with no life support system, but just 100 kilograms. It would take 133 years of this 500 gigawatt laser firing, which is 10,000 times bigger than any laser we've ever built.
And just in passing, I want to mention your praise for a book that I also loved, Kim Stanley Robinson, his Aurora, which examined the pitfalls of sending a colony ship to other stars. So basically, your conclusion is don't hold your breath for humans to make the trip to Proxima Centauri or anywhere further away.
Right.
So what you do propose, though, is this other sail-based concept that could get us out to these distances in a reasonable amount of time, where we could make use of solar gravitational lensing, right? But this means there are technological hurdles for developing these as well. I mean, just review that.
Well, the solar sail works on a different principle than the laser sail. There you pick up your speed by flying inward toward the sun, getting a lot of light power at a very low perihelion, as low a perihelion as you can stand, that is, that won't melt the sail itself. You don't want to be like Icarus and fly too close to the sun and melt your wings. So you fly as close as, now, if it's the mylar sail that we use in light sail, or even Kaplan, which they used on which the Japanese used on Icaros, and which NASA was trying to use on Scout, which fortunately they didn't get to fly. Those will allow us to get in pretty close. In the case of Mylar, maybe 0.3 of an AU. In the case of Kaplan or some of the advanced polyimides, maybe 0.2 of an astronomical unit, which is still quite practical for, that's much further out than, say, the solar probe, which got to 4 solar radii. This would be more like
Parker solar probe, yeah.
Yeah, 20 or 30 solar radii. And then to pick up enormous speeds as you go around the sun at perihelion with this enormous impulse of light power, you could get up to 20 astronomical units per year and get out to 600 AU in 30 years. You can even get closer with advanced solar sails, with advanced materials, carbon-carbon composites or metallic sails or ceramic sails of various kinds that people are investigating. And so research is being done on advanced materials, and there are a couple of studies now which say they might be able to get as close as 5 solar radii and get up to 50 astronomical units per year to get out to that distance, so you could do the mission in maybe 15 years. And so that would be quite exciting.
And I guess key to making this work is what we talked about a minute ago, that you're not talking about the SGL focus as a point in space. You don't really have to slow down your sail because it's going to travel on that line.
That's right. And I should mention the other enabling technology besides the sail is small sats, CubeSats, or anything that's, you want to have a very lightweight spacecraft, because if you have a heavy spacecraft, so you're not going to carry people there. You want to have a very lightweight spacecraft with a rather modest telescope, 1 or 2 meter telescope can do the job. And you want a lightweight spacecraft so that your sail does not have to be too big.
Really amazing, wonderful concepts at the core of this great book. It is just about on the hour. If you have just joined us, you probably already know that we are talking to the Executive Director Emeritus of the Planetary Society, Dr. Louis Friedman. We know him as Lou, the guy who hired me 23 years ago for the Society. Lou, we have questions coming in. I got a bunch more, and I'll try to fill in with some of those. But I
see the screen moving with a lot of them.
Yeah. Here we go. Well, beginning with, and I'm seeing them for the first time here, from Claudia Ornelas. Thank you for tuning in, Claudia. Considering the perspective of luminaries like Carl Sagan, who stated, absence of evidence does not mean evidence of absence, and considering Einstein's statement that why should the Earth be the only planet supporting human life? It is not singular in any other respect. And then Stephen Hawking's belief in the existence of other life forms in the universe, due to the vast number of planets. Here comes the question. How does your assertion that intelligent life is probably rare or even unique to Earth align with these viewpoints? Well, you've sort of addressed that through your solution. I
didn't really address that. And I think, it's a very good question. And now he phrased it in such a way as to make me embarrassed, because now I got to take on Carl Sagan and Stephen Hawking and Einstein and the whole group of them. But here's my argument. Astronomers in general believe in this idea that there's so many possibilities that there must be, where we're not unique. But you talk to biologists and you get a very different picture. Consider the Earth, just the Earth alone. We have hundreds of millions of species that have been here for 4 billion years. For the first 2 billion years, nothing was here except a single cell species. We didn't have multiple cells. We didn't have any evolution to complexity. And even in the 4 billion years since then, we've evolved among these hundreds of millions of species. Not one had made it up to the evolutionary ladder of intelligence, and by intelligence, I use the phrase of being aware of the universe or being able to technologically signal yourself to the universe. That is, having some relationship with the universe. That's somewhat of an arbitrary definition. I know it leaves out dolphins and other species that we have a lot of respect for, but I'm using it in that narrow sense.
Yeah.
So only one was able to make it, and that only happened a few 100,000 years ago out of that 4 billion year history. And it's probably not, if we kind of predict the future, a species that would last another 100,000 years. So it's a minor part of the evolution of life on this planet. To assume that this goes on everywhere and frequently is a huge leap of faith, as I think, not a leap of logic. And so I don't think it's by any means given. I think it's quite likely there's life all over the universe, but the idea that it's evolved into a technologically capable or aware, intelligent species is not by any means a leap of logic.
So you make a good argument, but you wish you hope you're wrong.
I just have to jump in.
Okay.
We have now 600 years of looking at the universe and having the universe look at us and being aware of it, and we see nothing. It's another downer. The Fermi paradox, which I
where is everybody?
Is where is everybody?
I do want to get in that statement I started to make, that you make a good argument, but you hope you're wrong. Didn't you say that in the book? Well,
even me, who makes this argument, it's not gloomy. I think if we're the only life in the universe, it's pretty exciting and good, and we have a lot to explore, and it just makes us even be more respectful of ourselves and our planet and everything about us that we need to take care of. So I don't think it's a downer, but I have to admit I'm human, and I have this human feeling that, oh yeah, maybe it is a downer in some way.
I did see.
So I would be very excited. I would,
of course,
as anyone, to have a discovery of extraterrestrial life. And I've read lots of science fiction where I get viscerally engaged in the idea that we're making contact and we have this idea. It's part of our literature. It's part of our psyche to have that feeling. But I think it's still fiction.
I did see a sea otter smacking a sea urchin with a rock to break it open just a month or so ago. I mean, probably 4 or 5 years they'll have radio telescopes.
You can use that to make a rocket ship. I'll withdraw my statement.
All right, here's another one from Jeremy Kokol. Really enjoyed this book. Lou provided an amazing dance using the words possible, impossible, practically impossible, probable, improbable, and of course, a bridge too far. He even includes that great appendix discussion where Carl Sagan mentions we have not witnessed what is possible and what is not possible. It takes me back. It's another major theme in the book that you mentioned a few moments ago. This, we'll call it a discussion between astronomers and biologists. But why did you decide to include that great debate?
Well, first of all, for your people who didn't get to the appendix yet, this was a debate that we published in the Planetary Report between Carl Sagan and Ernst Mayr, who was a very famous biologist at the time, and a more negative view on the possibilities of finding extraterrestrial intelligence. And I remember at the time, I was not deeply into this subject, so my cursory feeling was, well, of course, Carl's Planetary Society, I'm on his side, and that kind of. But as I got into the subject deeper in preparation for this book, I realized it was this sort of differing worldviews of astronomers and biologists that that I was contrasting. And when I give talks about this book, I show the time scale, and it's in the book. I have a time scale of the life on Earth and this evolution that I have been talking about to reach the intelligent species. And I also have a distance scale of space between here and Alpha Centauri. And I talk these scales they conjure up different feelings between the biology and the astronomy. So I thought it would be useful. Of course, these are two great people, Sagan and Mayer. And so I thought it would be useful to republish what we published in the Planetary Report some 25 years ago to put it in this book. And so I did that.
It's fascinating.
With the permission of the Planetary Society.
Of course, like they would refuse you. Here's the question that Jeremy actually had. You got a lot of people here who, want to remain hopeful about intelligent life elsewhere. Do you remain optimistic that much of what seems currently impossible with space travel across vast distances will be within our grasp as humans, given enough time? Might we be traveling light years away within, he proposes, 1,000 years? That's assuming, that Zephyr Cochrane doesn't develop a warp drive in a century or so from now.
Well, as Carl used to say, prediction of the future is a lost art. And so I have a somewhat different view of this. To be honest with you, I'm not going to actually say it's my view. I'm just going to offer it as a challenge. The evolution, again, of humankind is moving very rapidly. It's only been 600 years since we invented technology. It's only been 50 years since we've been able to leave the planet. And it's only been about 20 years that I can summon a car to pick me up at the house here with a punch of a button on my wrist. What I'm trying to say is that intelligence is evolving into ways that we don't know yet. And everybody is familiar with the questions about artificial intelligence. And there's a whole theory which says that maybe in some number of decades or 100 years, we might reach a singularity where the human species might be either supplanted by or have to live coexisting with a next stage of evolution, which is more involved with artificial intelligence and robotics and silicon and all of that. So organic life may not be the future of our contact with the universe. So, and I don't know the answer to any of these questions, of course, but I think that's even more likely than humans solving the problem of interstellar flight in a practical sense, of warp drive or flying through wormholes or any of those science fiction ideas. I think the answer is not going to come from imagined but not yet realized physics. I think the answer is going to come from things that are way beyond my thinking in artificial intelligence and the relationship and interrelationship between information and biology.
Well, let's bring it back into our solar system with a question from Violet Paola.
Something I know something about.
Violet says, do you believe that extraterrestrial intelligence might have existed on planets like Venus, but self-destructed, as you discuss in your book, about the potential for intelligence to vanish due to catastrophic threats? What's the quote? I don't know how handy it is. I think you say at one point, because you open each chapter of the book with these really nice pithy statements. Here it is. There is no evidence that intelligence helps species to survive. There is some evidence that it does not.
Well, of course, there again, I'm drawing on the experience here on Earth. We have species that have been around for thousands and millions of years and tens of millions of years without intelligence. only one species with intelligence, and their lifetime is probably going to only be on the order of fractions of a million years, and more like tens of thousands or hundreds of thousands of years. So that's where that somewhat provocative quote you cited comes from. We never can say what hasn't happened. You can't prove a negative in science. We could all be extraterrestrials that had just got here, or I could be an extraterrestrial that just got here, and now I'm making myself look terrestrial. You can't prove.
I've suspected for many years.
You can't prove a negative in science. So whether or not extraterrestrials came to other planets or are hiding out in the asteroid belt, as some people have hypothesized, or have made their presence here, come here and found nothing interesting and left, and they'll be back again in another 40,000 years. There's all kinds of things you can imagine. All these things have been written about in both science fiction literature and in various conferences on SETI and so forth. You can't prove them wrong, but there's no evidence for them. And that's the key. With all of these ideas, nothing has been found. And while we can never say it's impossible, we can, after a while, say, if you don't find it long enough, maybe it doesn't exist.
Let me turn to our other planetary neighbor in the solar system, Mars, because you do talk about the importance of Mars sample return, MSR. As you know, still a very important priority for the Planetary Society and NASA. But we have just in the past few days been hearing that there are some significant challenges facing that effort, at least as NASA currently envisions it. Can you talk about, your current feelings about where we are with that? And
sure, that's a loaded question.
Yeah.
First of all, a lot of your Planetary Society members may not know that before the Planetary Society, when I was at JPL, I actually had a brief stint as the head of the Mars program and led a Mars sample return study, a fairly significant one, a joint study of JPL and Johnson Space Center for NASA. However, NASA decided not to do any Mars exploration after Viking, and so that study was put aside, and that's one of the reasons that we ended up forming the Planetary Society, because we wanted to do Mars exploration. But the current Mars sample return is a very complicated mission, has lots of parts. It's being driven by a lot of scientists with many objectives, and it's expensive and it's very complicated. It also has places where things can go wrong, single point failures like the Mars ascent vehicle or the rendezvous in Mars orbit. So it's not a resilient program. I think it needs to be made more resilient, and a recent independent review board study of the JPL work basically said the same thing. They said, take a little longer, maybe add another rover to it, maybe even they'll build two vehicles and have two launches. I don't know how it's going to come out, but it does need more resiliency. Another thing I think that's a mistake in the program that harkens back to our days of testing Mars rovers back when we were doing that in the 1980s. We did it with the Russians for international cooperation, not because we were trying to help the Russians, but because we were trying to get it to be part of the American space program, which it wasn't. And so we helped introduce rovers into the program at that point. Something like that. There's another country now doing a Mars sample return, China. And China's doing a Mars sample return by the end of this decade. Now, their mission is much simpler. It doesn't have anywhere near the scientific scope or engineering scope that our mission has. And they might not be successful. It'll be their first such a complex Mars mission like this, although they have now done a lunar sample return, and they have done Mars rover. I think it would add resiliency to basically the whole exploration of Mars if we and the Chinese cooperated, at least, if not in an engineering sense, at least by exchanging samples. Now, I know that's politically incorrect right now. There's more people who want to put their heads in the sands relative to China. But I think that from a science point of view, as well as from a Earth point of view, it would be better to cooperate on something as benign as exchanging Martian samples. There's probably no secrets in the Martian samples that threaten our national security.
I'm with you on that. We need to bury our heads and more in that Martian sand and get those tubes back to Earth. Let me get to another question here as we get into the last quarter of our time together, talking with Lou. This one is from Philip Shane. Frank Drake once said, if we had a telescope at the solar gravitational lens position, that focus, we would be able to see taxicabs on another planet. Is that correct? Was Frank a little too optimistic?
Did Frank say that?
Well, I only have Philip Shane to rely on here.
Actually, if I could find that quote, I'd like to have it. That's what I thought once too, because when we started in on this, that 100 billion times magnification kind of leads to the conclusion of taxicab. There's been some perturbations in that, maybe not quite so optimistically. We might only get to see something of like trains or of that size, maybe not taxi cab size. So, but it would be a step in that direction. If you'll excuse me, I'm going to let my dog out the door here.
Sure. That's important. Speaking of other forms of life, did he make it?
No, my dog is not intelligent life. He doesn't realize that.
All right, you can speak for your dog. Mine's very sharp.
Frank is right in the basic calculation and the basic point he made, if he said that. But I think now the practical limit is we will hope to see signs. If there's technology on another world, we would see it with the solar gravity lens. We would certainly see signs of a technological civilization. We would see the highways that the taxi cab is on.
That is a very exciting prospect. Here's one from Susan Stalker. Hi, Susan. She says, hello, Lou. Thanks for everything you've done. I would like to know if you foresee humankind becoming one of Kardashev's type 1, 2, or 3 civilizations. What do you think are the biggest hangups that we will have to work through in order to achieve any of these tiers of society? You do talk about this work by Kardashev, the type 1, 2, and 3 civilizations in the book, but you may need to give a couple of sentences to reviewing that.
Yeah, the basic idea is that Nicholas Kardashev, who was actually a colleague of Carl's and mine back in the day, he's now passed, and a steady pioneer in many ways, hypothesized or categorized for the purposes of thinking about the possibilities of an extraterrestrial civilization signaling us. Kardashev type 1 civilization basically harnesses the power of our planet, of the planet. All the power on Earth used to signal ourselves would be a Kardashev type 1 civilization. Right now, we use about 100th of that power or even 1,000th of that power in any kind of signal attempt. So we're not anywhere close to even being a Kardashev type 1 civilization. A type 2 civilization would use all the power of the sun, the solar system. The whole power of the sun would be used behind the power of the signal that you would try to send yourself there. And a Kardashev type 3 civilization uses the whole power of a galaxy to send out a signal. So enormous. And there are numbers that go along with that, the 10 to the whatever watts that has. I don't know that we'll ever even get to Kardashev type 1. Maybe we will in some way or another. I'm reading another science fiction book, which for the second time, actually, I read it many years ago, The 3-Body Problem by a Chinese author.
Oh, great book.
Which they hypothesize becoming a type Kardashev type 2 civilization by some mysterious effect of using solar electrons to magnify a signal from Earth, but it's fiction, so it's not going to happen. I can't get my head around that as a prediction at all. It's way beyond my power of thinking to reach that level. Again, it's trying to predict the humankind's future. My more modest goal would be in the lifetimes of the people who, or even in the lifetimes of the children who are people who are involved in this book club meeting here, to see if the human species could even become a multi-planet species. I used to believe that was a certainty. I'm not so sure now. The idea that we would even set up a colony on another planet. Used to think that was inevitable. But again, our experience on Earth is we haven't set up colonies under the oceans, which are far more reachable and far more resource rich. We haven't set up colonies in the Antarctic. We have bases there, but we haven't set up colonies there. It's not at all obvious to me we'll set up human colonies beyond Earth anywhere. But to me, I consider that a downer. I'd like to see the human species be a multi-planet species.
Here's a related consideration, one of mine, about being around to celebrate when we find really good evidence that Earth is not the only cradle of life in the universe. Do you still hope that maybe you'll be around when that evidence is
I hope
found?
I'm around for everything. Yeah. Yes, I do. I mean, I open up, my computer every morning, hoping that some scientists will say he's got some unambiguous detection of life on another world. I don't think it can happen without, actually some next generations of telescopes and also the solar gravity lens eventually like that. But, I don't know. There are a lot of surprises. I didn't know about any of this. I remember saying, just to admit my ignorance, I remember when Sagan and Murray said, we got to get more into exoplanets. This was in late 1990s when the first one was being discovered. And I said, oh, come on, don't get us into that. That's astronomy. And we don't want to deal with Earth-based astronomy. We want to be about space missions. That's not going to be interesting. Shows what I know. Lucky I was working for them, huh?
Yeah, definitely. So here is what might be. Oh, wait, I got two more, I see. From Craig Griffin, I would still like to know about the holodeck reference in Chapter 8. I think what Craig is talking about is the potential that you see to immerse scientists and regular folks like me in an alien environment, in an extraterrestrial environment, using virtual reality technology. Am I on the right track?
Yeah, that's what I really do see as the future. The idea that we will get data from other worlds, first in our own solar system, from Mars, Europa, and Celadus, Titans, and so forth. And we'll have so much data coming back, we'll be able to build virtual reality and augmented reality models that we can immerse ourselves into. And we'll be able to display them not on screens, but on 3D holograms. And we'll be able then to go in and explore. And I was mentioning this to a group I belong to at the Explorers Club, and one of the people there said, oh, we do that kind of thing now. I visited a lost city, Guatemala, and we've got all that data, and somebody has produced a virtual reality model of the whole thing so that we can all go in and explore it. And so I see this happening with our exploration of other worlds, and I think that is a future that may supplant the need to send humans to other worlds. I don't know, but it certainly will bring home the idea of humans can be exploring other worlds and other planets in a much more participatory and a much more larger fashion, much more engaging fashion than the idea of sending human missions there every few decades or so.
I know some rover drivers at JPL who love their 3D glasses. So,
and there's where did I read this article just yesterday about we may be learning more about AI and how to use AI ethically from the rover drivers at JPL. I just read that article.
Oh, that's fascinating. I'd love to catch the reference to that. Hey, you can
Right.
share that in chat if you
Well, if I find it, I will. Or
thank you.
if you search on AI ethics from Mars rovers, I think you'll find it.
I bet that'll work. Hey, and for you, Violet, because I'm not looking at the chat channel, maybe you've already done this, the chat thread. If you can find that, oh, I'm sorry, to Philip Shane, if you can find that Frank Drake quote, share that with us in chat as well. Here is what I suspect will be the last question we have time for today, because we are almost at half past the hour. And Amber Trujillo, doing her great job as always, supporting us with this, says, apparently the president is finally speaking. So
that's correct. I just looked over at the screen and saw the same thing myself.
So you can probably, if we wrap up here in the next couple of minutes as planned, you can still catch some of what the president has to say to us on at a momentous time in our planet's history. Here it is from Robert Johannesson. A comparative astrobiology question for Lou. SGL, solar gravitational lens technology, would provide more detailed spectroscopy than we have today. We would learn about chemical compositions of exoplanet atmospheres. We'd be able to see pretty pictures of forests, seasonal changes, maybe even animals swimming on the surface of alien oceans. They better be big, blue whales maybe. But do you envision any methods that can be used to learn about the genetics of exoplanet life? What kind of replicators do they have, or replicating molecules? An interesting thing to compare. Do you agree?
I certainly agree. It's an interesting thing. And I have wondered about that. And I haven't come up with it yet. I have the vague idea that perhaps there's something we can probe into an atmosphere that can affect that and get that signal back in some way or another that could give us that kind of genetic information. But I haven't heard or seen anything like that yet. Certainly interesting speculation, maybe related to the spectroscopy where we get the emissions of gases or things that are happening. But to see things at the molecular level through the solar gravity lens, even for my friend, and by the way, this person who wrote this question, I suspect he's a friend of Slava Turishev's, because to bring up the importance of spectroscopy through this solar gravity lens is something that Slava's been talking about, written a couple of papers on now, quite important. And another researcher is beginning to get interested in that as well. So maybe that is an area that will pop out as future research.
So kudos, Robert.
That's why I'm optimistic. There's a lot to explore out there.
Aren't we
Don't
all?
let my conclusions be negative.
That's why we're members of the Planetary Society. And it is all of you out there who, of course, make programs like this possible, all that other great work that we do. So keep thinking big. I'm not quite done. Lou, what are you up to now? What's next in the life of the executive director of Emeritus?
I wish you hadn't asked me that. I don't know. I've written 4 books or 3 books during retirement here. I'm involved with the solar gravity lens focus studies. We have a spin-off study that I'd like to try and get some work done on, which is using these fast missions through the solar system to go to Enceladus 10 years faster than anybody's thinking of doing it now, or going out to Uranus and Neptune 20 years faster than people are thinking of doing it now, or to get into the Kuiper belt and look for Planet 9 or Planet X or whatever you're calling it, or the idea of maybe a black hole in the interstellar medium. So we're looking at some of these fast missions through the solar system to enable things to be done more quickly that could otherwise not be done in a few years.
Fascinating, Lou, as always. You finish the book, at least prior to the appendices that we recommend, by coining another great term, SOTI, SOTI, the search for our terrestrial intelligence. Say something.
Yeah, that was an opinion piece based on the sort of reaction to so much of the early part of SETI deals with the taking it out of the pseudoscience region and trying to move it into science. There's, some ancient aliens have abducted me, or ancient aliens left crop circles here, or whatever, that people think of when they think of extraterrestrial intelligence. That's pseudoscience based on either anecdotes or just storytelling. And then to move SETI, we got it into science, and it was a struggle. Well, now we're in an era where pseudoscience again has reared up to replace science, and subjects like evolution have become debatable, if you can imagine, by pseudoscientists being of political influence. And so much of the health field, as we saw during COVID, and the arguments about vaccinations, and the idea of pseudoscience influencing our politics. And so I kind of been wondering where it's happened to our terrestrial intelligence. And that's basically, that piece basically goes back to that theme of trying to let the science be the determining, or try to think critically. It's not even saying you have to be scientists or science about it, just think critically.
Lou, you and our members who participated today and across the world have provided good evidence that not all is lost. The search for terrestrial intelligence can be successful. Thank you so much. It is always fun. It is always stimulating and fascinating to talk with you. And I'm glad you could join us here in the book club.
And hello to all you Planetary Society book club members. Great to see you in a new environment and a new venue.
We are going to be back before long, end of October, to talk about another fascinating book. And you can check all this out in the book club channel here in the member community. The one we've been talking about today, there it is, Alone But Not Lonely, Exploring for Extraterrestrial Life by Louis Friedman, with a foreword by Mae Jemison, his good friend and the first African-American woman in space, who provides a very thoughtful foreword to get this book underway. Again, Lou, thank you very much, and I hope to see you soon.
See you soon.
Thanks, everyone, for joining us today, and I will definitely see you again soon as well. Bye-bye.